Perfect Plumbing Plan, a Build Original series brought to you by SharkBite.
Hi friends, Matt Recirc here with The Build Show, and I'm excited to kick off our new series, The Perfect Plumbing Plan. We're partnering with a company whose brands you already know from the job site, RWC. They're the makers of SharkBite, HoldRite, Cash Acme, John Guest, Eastman, and EasyFlow. Under one umbrella, RWC can give contractors almost everything they need for a potable water system. From the meter all the way to the fixture, all backed by one warranty and over a century of combined innovation. Let's break it down. SharkBite is the leader in push-to-connect plumbing. They also manufacture PEX A and PEX B pipe along with all the methods pros use today: expansion, crimp, clamp, and soon press fittings. And because they engineer the full ecosystem, the components work together cleanly and reliably. Now, HoldRite is all about solving job site challenges. They're the industry leader in pipe supports, acoustic and vibration control solutions, fixture outlet boxes, fire stop sleeves, drain waste vent testing systems, and water heater accessories. Now, Cash Acme has been making control valves since 1912, over a century of engineering behind the products that protect our systems. They're the leader in water heater T&P valves, and they provide the pressure reducing valves, thermostatic mixing valves, and heating valves we depend on every day in residential and commercial work. John Guest is the world leader in plastic push-fit fittings, tubing, and fluid control products. If you've used modern tubing systems, chances are you've touched John Guest quality. Eastman has been around since 1955, and they're a leader in water supply lines, gas connectors, and water heater accessories, all the small but mission-critical components that keep a plumbing system reliable. And finally, EasyFlow, serving the industry since 1979, offers a wide range of plumbing products and kitchen and bath accessories that builders and remodelers rely on every day. And that's why the Perfect Plumbing Plan is built around these brands. I'm Matt Recirc, and I'll see you in this series. Let's build smarter and let's build better. Ross, Eric, welcome.
Yeah.
Come on in. Welcome to my house, guys.
All right.
Good to see y'all. So, Eric, you've been here quite a bit. Ross, this is your first time at my house. You've seen the plans. This is meant to be a case study episode where we kind of go, all right, I built this a couple years ago, and I used that hot water Recirc kind of system, a loop that has all these twigs out from it. Let's test it and actually see how it did. And I'm going to tell you some real world things that work well and maybe don't work well. First though, Eric, why don't we give him a little bit of layout? You saw this under construction. Why don't you give him the quick tour?
Yeah, let's go take a look. We could just start at the water heater, which is in this really cool hidden kind of cavity here.
Oh yeah, look at that.
The main level.
My hidden door.
Yeah, so this is slab on grade construction. We don't have a basement like you and I are used to, right?
Yep.
So everything's got to either go up and down or up and up. Right, so
got it. Yep.
We've got water coming in. We've got a smart shut-off system.
Yep.
We've got filtration and water conditioning, and then we are feeding this heat pump water here. So storage tank because we're generating the hot water from an outdoor unit.
Yep. Okay.
From the heat pump, because we're at a little bit of an elevated temperature, we want it safe to the sinks, we've got a thermostatic mixing valve.
Okay, got it.
And then like Matt said, we've got a loop basically in the ceiling above us because there's a couple bathrooms upstairs.
Okay, similar to the plan that we saw in the last episode?
Yeah, maybe got installed slightly differently. You know how it is when you're out on the job site and you and the plumber are figuring out where should we run this. But in effect, this is a I-joist ceiling above us here.
Okay.
I think there's 16-inch deep I-joists. And I used PEX A, pretty flexible, right?
Yep.
So I've got a 3/4 line that basically comes up out of that closet and runs in a racetrack around this ceiling. What you can't see yet is right above us, Ross, is my daughter's bathroom right here.
That's right, yeah.
And then almost right above the refrigerator over here is my boys' bathroom.
Okay.
So that line kind of comes through the ceiling right here. And then you showed it on the plans yesterday. This is where that 1/2-inch twig comes down. And I think it's so interesting, you've never been here, but you were able to see, oh, on the plans, you got a big window here.
I saw this, and I was considering.
You can't run a line through the window direct to that. So obviously you ran it down and over and up.
Yes.
And so I think it would be fun for us to test this. I don't have a charged line right now.
Okay.
Let's see how long it takes with no pump on, no charged line, because I think you estimated it yesterday. Do you remember the time?
Yeah, I think it's 58 seconds, so round up to 60, based on the math going from there over to here, coming here, and then dropping down here.
Yep.
Pretty darn close, maybe a little bit shorter based on the new routing that you just mentioned, but we should be about a minute.
Okay, so here's my Thermapen I use when I'm cooking my steaks.
Yeah, I'm gonna do the stopwatch.
Let's do the stopwatch, and let's go. By the way, we're in Austin, Texas, so the inlet temperature is pretty dang warm here, Ross.
That's right.
So I think I lied to you. I think my system was actually pre-charged. Because look,
It was about 10 seconds.
But it took us 10 seconds to get there. So, okay, I was wrong. Apparently my wife maybe was in the house and used some water. So on a best case, we'll have to come back later and check it again.
That's right.
It actually is working as intended. I just didn't realize someone had used some hot water already.
About 10 seconds.
About 10 seconds to get hot water here.
Yeah.
Now, if that line wasn't charged, though, and we had this huge slug of cold water to get out, it would have been pretty long, right, Eric?
Yeah, so we go back to what we talked about in the studio with the pipe sizing and the fixtures at the end of that pipe, right? This is a 1.5 gallon flow faucet.
Is that what these typically are?
1.5 to 2 gallons at most for a kitchen faucet is very typical, unless they...
Could be a low flow at 1. It could be a lower flow.
Yep. And so as soon as we get to that level of flow rate at such a slow velocity, feet per second, you've got that 3/4 inch line. It's going to take upwards of a minute or more to clear that out. To purge that cold or cooled down water from the tank. A couple things too that you have to realize with a thermostatic mixing valve is there's a little bit of time to temp for that mixing action to get the cartridge in the mixing valve into the right position to deliver the hot water, because you've got 2 different temperatures feeding and that cartridge is trying to mix it to where you've set it. That increases the time to tap a little bit, but it's a necessary item in the plumbing system. We see them all the time, so it's very common.
That's right. But the Recirc system here is the key that gets us water
quickly,
basically in 10 seconds or less. Right? And that's really where we're trying to get to. If we get to 5, even better. But without the Recirc system, you're going to be waiting for a long time to do that. The other thing too is you could pull up your automatic water shutoff valve and you can actually see the flow rate instantaneously. So we can see exactly when you turn this on. Is it running 1 gallon a minute? Is it running 1.25, 1.5?
That's neat.
Up to 2 gallons a minute. Yeah.
Now I got to tell you, let's walk back to the water heater, because when I first planned this house, to be honest, I didn't think very long about time to tap. And it wasn't until I saw this guy, Gary Klein, our mutual friend, speak, and I talked to him about my plan, and Gary said, why is your water heater in the garage? And it's a little hard to tell where that garage is while we're here, but it's at least 20 more piped feet that direction. Now, on the exact other side of this water heater is my shower, and then my 2 lavs for my wife and I over there. Let's walk over there and get a time to temp there without the pump. It's not on the circulation system. So let's walk over there and do that. Ambient temp 71 in here. You ready? And let's go. And now it's heating up quickly. So it was about 15 seconds, I would say, maybe 17 seconds. Not bad though.
And that's probably a low flow fixture, right?
This is, yeah.
That's probably a half a GPM, something maybe in that order of magnitude.
Can't remember, to be honest, but it is a lower flow. So it's not moving a whole lot of water.
That's right. So that at half a GPM, you're going to be moving about 1 foot for every second through half-inch pipe. Right? So you do the math out, that checks out.
What's cool about this Kohler digital thermostatic is when I turn this guy on, you'll see that it automatically tells you how long it takes to ramp up. So my target temp always is 100, and then my wife usually showers more like 105. But check this out. When I hit the start button here, you'll see the temp go from cold. Now the shower started. So it's cold right now. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 7.
Look at that.
It took about 7 seconds to get up to temp.
That is fantastic.
Isn't that cool?
And that's the short run
right here. You can barely take your pants off before that shower is ready to go. And I lived at a house across the street before that had a water heater on one side of the house and the primary shower like 75 or 80 pipe feet. My wife would literally turn the shower on, get undressed, get some stuff out, maybe start reading a book.
Forget about it.
It took like 2+ minutes to get hot water.
Look, I've seen it dozens of times. Customers' houses, we are waiting. They're telling me minutes at a time, and I always want to think like,
really?
Are you exaggerating?
I think you're exaggerating, but I've witnessed myself too. I myself have a 2-story home, and I've got a Recirc, trunk and branch with a Recirc, right?
Yep.
But if I turn that Recirc off, it's a minute and a half, 2 minutes to get hot water all the way up to that far primary bathroom.
Yeah, same here, same with
That's miserable, and it's a ton of energy we're wasting. So you could show right here how simple it was just to say, hey, we moved the water heater to where it needed to be, right?
Yeah.
That's really what it came down to.
That's right.
It was just automatic that you were putting the water heater in the garage because that's what you guys do here.
Yeah.
It makes sense.
Yeah.
It's out of the way. You don't really want it in your living space necessarily, but you're able to create a space for it, which has now changed how you're operating your house or how you live in it, because you don't have to go and read a book or go do the rest of the laundry while you're waiting for hot to get.
Right, and you also changed the layout of this master bathroom, right?
Yeah,
the bathroom originally was further away.
Yeah.
So that hot water rectangle would have been worse. The time to tap would have been worse.
Exactly.
So by making those 2 changes, by moving the primary bathroom here and also moving the water heater from the garage to over there, you cut down on a lot of water use and a lot of energy efficiency.
Yeah, it made a lot of sense. Next up, I want to show you my daughter's bath and show you how we operate the Circ pump. So let's meet upstairs. Okay guys, so this is my daughter's bathroom, and this is kind of cool that I thought I'd show you. This is the hot water button that manually operates my pump. I have the Metlin demand system here, and it's not one that operates on its own. It needs a user to tell it, which I like because it only runs when you need it. So I've trained all my kids, hey, when you're about to get a shower, come up here and hit this button. This is basically just an instantaneous button that you'll see the light turns green, and it will stay green as long as the pump needs to run, but the pump turns off as soon as the pump realizes, hey, the water is hot.
So once that sensor sees that it's warm in the loop, it turns it off.
Exactly. So in this case, it only ran for a second because it circled the water. It was like, oh, the water's already at 110, let's say. That loop was charged because we were just downstairs running the kitchen faucet. So that loop was charged. So now, Ross, let's try this one and go. So we're starting at 68, and look at that, almost immediately.
4 seconds, 5 seconds, look at that.
Yeah, way under 10 seconds.
Yeah, 5 seconds.
And we didn't fake this for video, I promise. We literally, when that pump is has charged the line, the twig to get here is probably 5 or so piped feet of 1/2-inch pipe.
Right.
And we remember from your demo the other day that, is it like around 6 feet of 1/2-inch pipe is 1 cup?
Yeah. So you're probably taking about a cup or less, let's say less than 2 cups. The 5-6 seconds, it's because you were able to get that trunk, that main line, as close to this bathroom as possible. We didn't need it to be farther away. We're circulating that line. Very easy, simple layout, but less material even.
And for me, as a homeowner, I'll tell you, water is not inexpensive here in Austin, Texas. My water bill can be expensive. So not dumping water, a minute or 2 of water down the drain every time I turn a tap on is a big deal. Plus, there's 6 of us living in this house.
That's right.
So I got a big family. And from your chart that we talked about on episode 1, I think it was, I mean, think how many water draws my house has on a day when we're all in the house. Like on a Sunday when everybody's home, right?
Yep.
There's a ton of water. We probably have 100 water draws plus.
With 5 people? Yeah, you might have that many.
Well,
yeah.
Let me interject though. As the plumber, as the person that deals with the customer, the homeowner, that has the complaint of waiting a long time for hot water, you should see how people's attitudes change when they have not yet had that Recirc system and they did have to wait, and then I put it in. And instant change, right? Like, it's amazing that you don't have to wait for this. It actually does kind of make your life a little bit better.
Yeah.
We talk about the energy, we talk about the savings, but ultimately, it's a huge convenience.
Yeah. Let's actually talk about that here. This is a tight bathroom, but we're gonna try it anyways. You're gonna see a supply line on the right here, which is her cold line. Supply line on the left, which is her hot line. And you don't see the Recirc system because the Recirc is in the floor. But Eric, if this was your furthest bedroom away, you could actually add a Recirc under this sink, couldn't you?
Yeah, so the new Recirc systems are really cool. They can be retrofit into existing piping systems that don't have that dedicated return line back to the mechanical space, your water heater. We can put what's called a crossover valve. It has a little thermostatic valve inside of it, and the pump communicates in a way, not with any wiring or anything, but by temperature, and it tries to push that hot water it's drawing from the water heater into the cold side of the plumbing.
That's right.
Now, that's not really that big a deal. You're going to hear that and say, well, why would I want hot water in my cold plumbing? We're talking about a sink that's far away. You're not typically using a lot of cold water in a bathroom. Believe it or not, it's more hot water use. And having the convenience and saving the energy and the resource of water by not letting it go down the drain is worth having a little bit of warm water in your cold water side.
Yeah, that's a great retrofit solution.
Yeah. See that extra pipe right here? This pipe is a PEX pipe, but it's coming off of my drain. That line is taking just a little bit of water every time the drain is used. So when the water in the sink runs, just a little bit of that water kind of pees down this little tube right here. And that's what's called a trap primer. And if you look on the floor behind me right here, I've got a floor drain integrated into my Schluter waterproofed floor. So if I had an emergency, shower overflowed, toilet overflowed, something happened here, this floor drain would catch it. I also put a marble threshold in to separate the tile from the hardwoods. It's just a little bit of a lip, with the idea being that the water would go down this drain. But because this drain doesn't normally have water going through it, we need to prime that trap. The P-trap that's in there would get dry and we'd smell sewer gas. It'd be nasty if we didn't have a trap primer. So instead of using a wet primer or basically a water line with a device that would dribble a little water in there, we basically took this line here, and on the P-trap here, there's an input line for PEX, and now every time the sink runs, a little bit of water primes this trap as well. It's not necessarily related to time to tap, which is why we wanted to come here, but I think it does relate to plumbing best practices. One of the most expensive things for homeowners insurance is flood.
That's right.
And every time someone has a flood event, whether it's a toilet that overflows or a pipe that has a problem, it's crazy expensive. I'll have to look up the numbers. We'll lace it in here. But it's in the thousands or tens of thousands of dollars when that happens. So by spending a little extra time and money on some floor drains, it can make a really big difference.
I like that it's not mechanical. There's no electrical there. It's just a very simple trap primer.
Passive. Yeah, I like how it's passive. Yeah. It's great planning. It's great planning. If there is ever a leak here, you're covered. Right? Yep. You're not going to have that catastrophic damage.
Now, Eric, you've used some other options for Recirc as well besides this system. Let's go back downstairs and we'll get Eric to explain another option.
Awesome. All right, Matt, so you've got this dedicated Recirc line in your plumbing system. It's drawing water from the farthest point back to the water heater here. Pretty cool system. It's not fully automatic. You've got some temperature sensors that you have to deal with. They have to be placed in the right space. And then it has its own kind of control box.
Yep.
Your interface, though, is the cool push button. I like that. I've also seen things like motion sensors to turn on pumps. If you walk into a bathroom, you might need hot water. It's just going to circulate the line for a few seconds. That's great technology, but things have changed in the last couple of years. And so we have some new pumps out there like the Grundfos Alpha, and it can just operate on its own. No interface at all. It does it with some sensors and some really cool algorithm built into its programming. Very simple, super low energy, and automatic. I think my customers like the automatic the most because they just expect the water to be hot when they come to this faucet, and it is.
And so how does that work when you say automatic? Is it just running 24/7? Is that what it's
not. See, that's one of the biggest problems with hot water Recirc is that they're not controlled properly. So we're not saving a lot of energy if we're just running that line hot when we don't need it. Think about when you're sleeping. You're definitely not running the hot water for no reason at all.
Never at 2 a.m. have I used hot water in this
But
house.
most of them are installed that way, right? Most of them are just 24/7, 365, just looping around.
Or maybe a timer too, right? Where we used to do, back in the day, we'd do a timer from 6 a.m. to 9 a.m. and then again from 4 to 10 or something like that.
Yeah, and like the Grundfos and some other pumps in the market, there's some really cool tech built into them. You can interface with your phone. You can set up timed events. You know, if we're only going to use water during this point of time in the day, then we're only actually going to allow it to operate that time of day. That makes sense too. It saves energy.
Yep.
How it does it automatically is it just uses a sensor, a thermostat built into the pump, and it's measuring time for the water to come back to the unit hot. It also sees when you're using your water, so it knows when it needs to operate.
Interesting.
It's very intuitive, and it's all built into the unit. So there's really no interaction with it, which is really nice.
One thing about this system that I've really liked is you can see in here, we put some pretty thick walled insulation everywhere.
Yeah.
And so when my line is charged, just like when we checked the kitchen sink an hour ago, it doesn't cool down very quickly. It takes a good 45 minutes or an hour to really cool down.
That's right.
So if you do a shower 20 minutes after the last person showered, you're good to go.
Yeah, it's super important. We haven't covered a lot of that with the insulation. We did mention it in the last episode, but we want to match the wall thickness of the insulation to the size of the pipe, minimum. You can go even larger. I mean, there's a diminishing return there, but the insulation is key and properly installed too. No gaps, no cuts in the insulation, and a high quality product as well.
I actually paid my boys while this house was under construction to insulate my hot and my cold lines. So there's a little hack for you.
There you go.
Get your 12-year-olds to insulate your hot and cold lines.
It's important work though, and it saves a lot of energy over the life of the house.
Makes a huge difference. Keeping that loop warm once it's primed and ready to go.
Yeah.
Should we check the kitchen sink?
It's been about that amount of time, hasn't it? Yeah, let's try it again.
All right, now that the loop is cold, let's try it again without the Recirc pump running.
Okay, you ready?
Yeah, let's
go.
58, 59, look at that, a minute.
Yeah, we're 110, 113 degrees. So you can tell, Ross, it makes a big difference having that line pre-charged. We're dumping maybe a cup or two versus how many cups of water could you estimate that to be? A minute's worth of dumping down the drain? That's a lot.
It's a lot of water, right? Think about it, we got about 45 feet of total length of 3/4, plus then we have about 10 feet of 1/2 inch to get here. Every single time you start your kitchen sink, you think about all that purged water you have to get out, right?
Yeah.
Of lukewarm, tepid water to get that hot water there. 60 seconds to a minute. And think about over the course of a year, all that time, how much water is wasted, how much energy is wasted, and the convenience, right, of just having that water there fast.
For
the
sure.
demand recirculation system makes a lot of sense.
And if we could tie this back to our last episode, Ross taught you the 3 options, right? We talked about the trunk and branch, which we've used for years and years, which you can add some Recircs to that, and that can work. Then we talked about the manifold system. If I have 45 feet of pipe plus that twig, but I only had a 1/2 inch line, I still would have had at least 30 or 40 feet of 1/2 inch line if I had a manifold. That would still take a while to get water there, and it's harder to do a Recirc with that.
Yeah.
So this system where I've got this Recirc system that's charged, small twigs to get rid of, it made total sense for me to do it on this house, and it's worked extremely well for me.
Yeah.
The one thing that I don't always love, though, is thinking about the button system. So Eric telling us about some other pump systems out there. It's cool to see that there's other technologies maybe to operate those pumps and make them kind of automatically happen.
That's right, yeah. Some of our clients, they don't like the push buttons. Some people want the motion sensors, so they walk in. Some people just want it to work automatically. And I think that's where we're going with domestic hot water Recirc systems, is the automatic. Let scheduling and AI kind of take over to make sure that those pumps run when you want the hot water.
I like it.
Yeah.
Let's go back to the studio. We'll catch up with Eric and we'll finish up the episode. All right, y'all, let's wrap up this case study episode from my house. I'm curious, Ross, you'd never been to my house before, but yet you did all the calcs on 3 different plumbing systems, and we ended up doing one of those.
Yeah.
What's your takeaway after seeing my house?
Well, first, I always love it when we do a design and the measurements that we measure in the field match up. So the fact that 10 seconds and about 60 seconds for the 2 different versions, that lines up. So that's always reassuring to know that. But I mean, the takeaways there is that Recirc pumps work, You can install a Recirc pump and you can put in the push button timers if you want that kind of manual control. You can add in a different type of Recirc for a different type of house.
And on more
Recirc
automatic.
pumps work, You can reduce that time to tap. You can get that water really fast. And so it's just great to see that, it works.
The other thing I want to mention real quick, Ross, is that, the other thing we did there was really pretty standard pipe sizes. That Recirc line is a 3/4 PEX A, and then all my twigs were 1/2 inch. So, when I originally was planning the house, I was thinking about doing 3/8 in a bunch of places.
Sure.
And I knew that I was in a jurisdiction that wasn't going to allow that. And I could have had you or someone else engineer it and stamp it.
Yep.
But I also did not think that my inspection department locally was going to approve it.
Sure.
So I went with more standard stuff. We engineered it.
Yep.
Someone helped me. And boom, we've got a system that worked really, really well.
And the fact that you made those changes to the plan, right? The fact that you moved the water heater location to a much more central location relative to the fixtures that were there for your hot water rectangle, like we talked about. The fact that you got your master bathroom rotated closer to the water heater. Those small changes make a big difference.
Yeah, they really do. Any big takeaways after seeing, you've been in my house many times now, Eric?
I think what Ross is saying is pretty important.
I've been a plumber for nearly 30 years. You've been building that long. You think you know it all, maybe, right? I mean, we're pretty good at what we're doing,
Sure.
but there's always room to improve. So you called in a professional. You got some great advice from our friend Gary Klein.
Yep.
Moving the water heater closer, which reduced your pipe lengths, which reduced your volume of your system, wait time at the faucet. I do want to mention the pipe sizing. Wouldn't it be great if we could see all of what we've talked about get put into play, where we get some code changes and we could maybe then rebuild your house with some smaller pipes and see, do we need Recirc? Can we actually
that would be interesting.
eliminate some different components, some materials, connections, things like that, so we can lower that volume, lower the wait time.
That's right.
Be pretty cool.
Shout out to Chris and the plumbers that did my house too. I think as you're pointing out, hey, I was willing to make those changes. They were also willing to plumb it like I asked them. And say, okay, that's different than I might have done. I think they would have preferred originally to do a trunk and branch. But they were like, okay, yeah, let's do this. So I appreciated that. And I think that's one takeaway that I want you to think about here watching this. We've got an engineer, a builder, and a plumber who are still learning. You're hopefully learning from the series. We're trying to give you the tools to bring hot water very quick to your homes. But if you need to bring somebody like an engineer like Ross's firm in, or a Gary Klein or others, there's lots of good people when it comes to hot water delivery. Don't be afraid to get a consultant out. I think we've done a good job in these first 3 episodes of tackling that issue of wait time, and it takes way too long to get water. Now we got to tackle the next issue, which is running out of hot water that nobody wants. So the perfect plumbing plan, we'll see you next time on The Build Show.
Perfect Plumbing Plan, a Build original series brought to you by SharkBite.